Good morning to all. In the previous session, we started what are the properties of coefficient of approximation in Fourier series. Under that, we discussed 5 properties. 2 properties were discussed in the previous session. The remaining properties now we are going to discuss in this session. Let us start. Now, 2 properties we already discussed. The third property what we are discussing is called time shifting. Time shifting in Fourier's coefficient of approximation in Fourier series. Time shifting. Generally what we discuss in signals, in time shifting there are 2 shiftings. One is right shifting. Right shifting is called what? Positive shifting. Another one is left shifting. Left shifting is called what? Negative shifting. In this one we discussed x of t minus t naught. Here we discussed x. Now 2 type of shiftings we discussed here. Right shifting and left shifting. Right shifting means what? Time delay. Here left shifting means what? Signal advances. So here it is denoted by x of t minus t naught. This is denoted by x of t plus t naught. If a student comes regularly to college within a time stipulation of the college, for example before or on 9:30, no problem will be with that student. Whenever the problem will be rising, if students are late, that means not on time. So that is the problem for students. Similarly, if a signal arises in advances, no problem will arise. A problem will be arising with signal if it were delayed. So here between these 2 shifting operations, we are focusing our concentration only on x of t minus t naught. That's why we don't discuss that. So students have to understand this point. Time shifting means even though there are 2 shiftings, we won't discuss this one because this is advances on or before time. This is always late. Now this case only we are going to discuss. So here time shifting means what? It is applicable only for delayed signals, not for advanced signals. That is important point. Now just let us discuss this one. If x of t is a signal, the Fourier series coefficient of x of t is equal to let f of x. F of x. How much time delay? T naught time delay. Now, therefore, the Fourier series coefficient of a signal that is delayed by t naught, that is equal to e power minus j omega naught n t naught into coefficient of that signal. Now look at, this is exponential factor multiplying with the Fourier series coefficient of that signal. E power minus j omega naught n t naught. T naught is called what? Delayed time factor. Look at how much time is delayed here. That is here. With the Fourier series of the actual signal f of x. That is called time shifting. Now just look at. Now here, next property, very important next property. This is multiplication. This is multiplication. In arithmetic, multiplication means what? Addition, subtraction, division, what it may be. We need minimum 2 integers. Same concept here we are also applying. Whenever we are using the concept of multiplication, here we need minimum 2 signals. Therefore, let the first signal be x1 of t. Let the second signal be x2 of t. Now, the Fourier series coefficient of x1 of t be f of x1. Next, Fourier series coefficient of the second signal be f of x2. This is the first requirement what we need. Now just look at. Multiplication means what? Now we are discussing multiplication. Fourier series coefficient of x1 of 2 multiply with x2 of t, that is equal to, look at, equal to Fourier series coefficient of x1t into Fourier series coefficient of x2 of t. Look at how I am divided this one. This is equal to f of x1 into f of x2. This is very important concept of multiplication. Why? Now we have to compare with convolution, very important topic. Actually this topic is supposed to discuss in the third unit. This is here we are discussing under the small because of the property concept of Fourier series only. Again in third year, again we will be discussing this. Now just look at. Now students have to compare the difference between multiplication and convolution properties of signal. Very important, just look at. I am making a bifurcation here. Now, the topic is what? Convolution. This is the next topic, next property, convolution. Multiplication next, convolution. Now, convolution means what? Now, just look at. If two signals are there, if these two signals are combined together, a new signal will be produced. For example, a number equal to 7. Another number is what? 8. 7 into 8. What you get? 56 is a new number. 7 is different, 8 is different, 7, 8 multiplying. What will get? 56. A new number will be generated. Similarly, if two different signals are combining together, what is the possibility of creating a new signal? What is the complexity of creating new signal? That is called convolution. Here students have to make it one important point. In computers, data structures, algorithms, we use only one word that is called complexity of algorithm. Similarly, the same complexity is a synonym to convolution in electronics. In algorithms, we use the word complexity. In signals, we use the word convolution. What is the complexity of producing a new signal upon combining two different signals? The concept is called convolution. Here, just we are multiplying in math, but here in convolution, what is the possibility of creating the new signal? The possibility of creating a new signal is called convolution. The possibility is a difficult, okay, but is it easy? These three are called complexities. Complexity means what? Convolution. Make it a point. Now, here we need minimum two signals. Let x1 of t is a signal, x2 is of a signal. Now, Fourier series coefficient of x1 of t, this is equal to f of x1. Now, Fourier series coefficient of another signal, x of 2 is equal to f of x2. Now, just look at f of x2. Now, just look at. Now, Fourier series coefficient of x1 of t into x2 of t. This is equal to f of x1. Look at star f of x2 multiplying with f of x2 multiplying with a time period t. This is called convolution. Students, they should not confuse. In multiplication, we have to use only dot. The difference you should have only dot. That is star. Star is the whole and sole property, symbolic representation of convolution. In place of dot, don't keep star. In place of star, don't keep dot. The difference between multiplication and convolution. Just look at multiplication is just multiplying, dot representation. There is no multiplication with time period. Now just here we are multiplying with total time period t. That too, this is star. This star is the whole and sole symbolic representation of convolution. Somebody may ask you, what do you mean by convolution? Convolution means what? In signal systems or Laplace transforms or Fourier transforms. What do you mean? If two different signals are given, what is the possibility of creating a new signal if these two are combined together? In combining together, the possibility of discussing the complexity of creating a new signal, that is called convolution. This is called convolution symbol, convolution property. It seems to be multiplication property, but both are different. Just look at, this is only multiplying the Fourier series coefficient of x1 and x2, but it is multiplying with the time period t, total fundamental period t. This is convolution. Again, in the third unit, at the beginning, we are discussing this property in depth. There, that is the major concept. Here, this is the minor project. Okay, now let us discuss. The last property That is called time reversal. Time reversal. Now just look at Fourier series coefficient of any one signal you take, that is equal to fundamental of, that is the constant of f of x. Time reversal means what? Just keeping a negative sign between the independent variable t. Now just look at, now the Fourier series coefficient of x of just minus t. Now look at where we kept minus before the independent variable t. This is equal to f of x is as it is. Here you keep minus. T means what? Plus t plus x, minus t minus x. This is the Fourier series coefficient of time reversal property. Among all these properties, linearity property, scaling property, time shifting property, time reversal property, multiplication property, and convolution property. So the main focus will be on convolution. In university, 2 times they repeated this question. Actually, the question should be like that. What is the convolution property in coefficient of approximation in Fourier series, like that. So here again I am telling that there is a lot of difference between multiplication and convolution. Multiplication property is just to multiply two given signals of their coefficients, but convolution is not only multiplying. What is the possibility of getting a new signal upon multiplying two given signals together? That complexity of creating a new signal, that is called convolution. Again, I am repeating the important point. What is the important point? What is the important point? In design and analysis of algorithms or data structures, we use the word complexity. Now, in electronics, that means signal systems or transforms, Laplace transform, Fourier transforms, everything, we use the word convolution. There is no difference between these two. Make it a point. These are synonyms. This point students have to understand very clearly. Complexity is nothing but convolution in transforms. Fourier transforms or Laplace transformations, like that. Everything will be discussed again with in-depth concept in the third unit itself. Now again just look at, these are the important concepts we discussed in coefficient of approximation. Now just look at, now in this session we discussed coefficient of approximation in Fourier series. Here we discussed time shifting, we discussed time scaling, we discussed time reversal, we discussed time shifting. Now we discussed time signals multiplication. Here we discussed convolution. And one more property what we discussed is called linearity property. So these properties we discussed on coefficient of approximation in Fourier series. Again, the essence of this topic I am telling you. Just look at here, coefficient, not plural. This is singular. Coefficient means we have to apply the formula of x of t is equal to summation minus infinity to infinity c of k e power j k minus n omega naught t. Make it a point. Here this is coefficient of approximation, but coefficients plural. What are the coefficients in Fourier series problem? This is equal to a naught, an and bn. These three are different. This single is different. Here all the three are combined in the single format, that is called coefficient of approximation in Fourier series. Both can be used for solving Fourier series problem, but this pattern is very easy for us for numerical problems. Even though we can calculate in this way or either in this way, but we always prefer this way only. In the next session, we are going to start another concept. Thank you.